Now in this session, we'll try to understand various types of questions which comes under the category of finding the integral solution. Although there is no one category of question which appear, there are various types of questions which appear wherein we need to find the integral solutions. Almost everything, almost from numbers to algebra, and then from PNC to geometry also. So the concept of finding integral solution itself is very important, because the scope of framing the question is very much wide. It can come under number system, it can come under algebra, PNC, or geometry, right? Now I'm taking the very first question. This is of I would say the basic questions under integral solutions, which I call it of the form ax plus minus by is equal to c, where a, b, c are also integer, and we need to find the integral value of x and y, or the integral pairs of x and y, right? So in this question, we need to find the positive integral solution. Always remember that this kind of statement, the phrases are very important, because here positive integral solution means that we need to find natural number solution, right? Had it been non-negative integral solution, then we would have found the whole number solution. That means the 0 x or y equal to 0 could also be the solution, but here x and y being 0 is not allowed. So let us understand the approach of solving such kind of questions. Here the coefficient a, b, c are very important. These coefficient itself actually gives us a lot of hints that how we can minimize our efforts also, right? So I'll be first of all discussing the basic approach of solving such questions. So here we have 2x plus 5y is equal to 100, and we need to find the positive integral solution. So we need to find one pair or one value of x and y. By hit and trial also we can find, and at times if the coefficients are not that easy, then we can proceed in such manner, which is like, say, we can write 2 of x as 100 minus 5 of y, and the value of x can be written as 100 minus 5 of y by 2, which can further be written as 50 minus 5y by 2, right? Now x need to be integer and y is also integer, so we have to take y such kind of integer so that the entire expression also becomes integer. Now it is clear that y has to be multiple of 2, or we can say that y has to be an even number, right? And both have to be positive integer also. So the smallest value of y which we can take is y is equal to 2. So if I substitute y is equal to 2 here, the corresponding value of x would be 45. So this is one pair which we have identified, right? So if I just make a table here for x and y, then we can say that for y is equal to 2, the corresponding value of x is 45, right? Now the interesting thing to note here is that the next value of y would be 4. So if I take y is equal to 4, then if I substitute it here, then the corresponding value of x would be 40. You can verify it yourself. And here the important things or the interesting thing appear, and that is these values of y will be in arithmetic progression, and the corresponding values of x will also be in arithmetic progression, whose common difference will depend upon the equation and the coefficients of the variable, right? So as you can see, the next value of y we can take is 6. So here the common difference 2, 4, 6. So the common difference dy we can say is 2, and the corresponding value, if I take y is equal to 6, it would be 35. And here the common difference, as we can see, that is d of x, is 5. Now this 2 is nothing but the coefficient of x. So that means y would be the values of y would be in arithmetic progression, whose common difference would be the coefficient of x, and x would also be in arithmetic progression, whose common difference would be the coefficient of y. So that is a very critical concept we have to remember in such questions, right? Now following the further things, since we have identified the smallest value of y, the next thing what we have to do is that we have to find the maximum value of y, right? Now it is easy to identify that the maximum value of y, if we keep on increasing, this entire expression 5y by 2 can be close to 50 or less than 50, because x cannot be negative, right? And neither it can be 0. But if I take 5 of y by 2, it should be either less than or equal to 50, so that this entire expression should remain positive to certain that x is always positive. So from here we can say that y has to be less than equal to 100 by 5, or y has to be less than equal to 20, right? Now we'll be taking less than only I'm sorry, I took the equal to also, but it has to be less than, so that this entire thing has to be positive. So here we can say that since y is even and it is less than 20, so the largest possible value of y is 18. So this will keep on going till the value 18 appears, and we'll get the corresponding value of x also. Since we do not need to find the individual value of x and y, I'm not taking every possible values of x here. I'm just focusing on y because the numbers, the elements in y is simple. So this is an arithmetic progression. This is the common difference, and we need to find the total number of elements. So we know that any element, nth element is written as a plus n minus 1d. Right, this is the last element. Now here we can see that 2 is the first term, that is a, common difference d is 2, and the last term is 18. So this can be equated to 18. So if I substitute the value, so it will be 2 plus n minus 1 into 2 is equal to 18, or we can say that n minus 1 would be 8, and the corresponding value of n is 9. That means there are 9 pairs which are positive integer x and y, which will satisfy this particular equation. So this is a standard approach I talked about, but many a time we can manipulate the given equation to again minimize our effort. So let me take that thing also. So here I'll try to minimize the effort. So the equation is 2x plus 5y is equal to 100, right? Now let us just observe the RHS. This is 100, which is even, right? So, and in the LHS, for any value of x, whether even or odd, this particular part will always be even because it's a multiple of 2. And we know that even plus even is even, right? So this much term, that is 5y, should also be even, or we can say that y has to be even. That is what we have actually identified here also, right? Now further we can say that if y is even, then we can take y to be some multiple of 2, or let me assume it to be 2b, right, where b is any integer now. So any value which b will take any integer, the corresponding value of y will always be ensured that it is even. Now further we can also observe that 100 is a multiple of 5, right? Now here in the LHS, this much portion, that is 5y, is a multiple of 5. So this much portion should also be multiple of 5, because multiple of 5 plus multiple of 5 will give me final answer has to be multiple of 5. So from here we can say that 2x is a multiple, 2x has to be a multiple of 5. So we can derive that x2 need to be a multiple of 5, correct? So we can say that x can be 5 of a, where a is any positive integer. Now if I substitute the value of x and y here in the original equation, so we'll be getting 2 into 5 of a, so it will be 10 of a plus 10 of b is equal to 100. Dividing it by 10, so it will be a plus b is equal to 10. Now this is very simple equation. We can we do not need any kind of AP, GP, etc. to get the required number of solutions. Here we can say that if a is 1, then b has to be 9. And if a is 2, then b has to be 8, so on and so forth. So the largest possible value which a can take is 9, and the smallest value corresponding for b has to be 1. So it is very evident that the number of solution is 9, and that is what we have identified. Although this but this is particular this approach is for general purpose, and such kind of manipulation is such kind of manipulation basically gives us a lot of flexibility to minimize our effort, right? So I hope this particular part is very clear. So let me move to the next question. Now in this question we have to find the number of integral solutions such that this equation is satisfied, as well as x should range between minus 50 and 50, right? Again we can observe that 3x minus 7y is equal to 120. This much number 120 is a multiple of 3, and in LHS this is always be a multiple of 3. Hence we can say that the second term should also be a multiple of 3. So here, since 7 is not a multiple of 3, so y need to be a multiple of 3. So let me assume that y is 3 times of k, right? So any value of k will give me the corresponding value of y as well. So if I substitute y is equal to 3k in the original equation, we get 3 of x minus 21k is equal to 120, right? Again we can divide it by 3, so that it will be x minus 7 of k is equal to 120, or we can say that x is it should be 40 here, or we can say that the value of x would be 40 plus of 7k, right? Now I have taken everything in terms of x because we have been given condition in terms of x, right? So x should be between minus 50 and 50. So we can say that 440 plus of 7k, which is actually the value of x, has to be less than 50 and has to be greater than minus 50, right? So let me subtract 40 in this equation. So it would be minus 90, 7 of k, 10, and again dividing by 7, so it would be minus 90 by 7 k and 10 by 7. Now it is simple to understand that this particular portion would be minus 12 point something, and that has to be greater than that has to be less than k, and k has to be less than 1 point something, right? Because 10 by 7 would be 1 point something. So since we need to find the integral value of k, so we can say that k has to be less than equal to 1 or greater than equal to minus 12. So we have identified the range of k, and we also know that if for each value of k, we'll be getting only one value of x. So the number of solution will start from counting all the integers from minus 12 to 1, which would be 14. So 14 is the answer. So you have just observed that a slight manipulation actually minimizes our effort. So always look for the coefficient, the multiple, even, odd. This helps a lot, right? Now let's move to the next kind of question. Now in this question, we need to find the number of integral pairs xy such that this equation is satisfied. Now this kind of question actually falls under the category of number system, wherein we need to have a fair idea about finding the number of factors and finding the number of factors of a specific kind, etc., right? So what we can see here is that 1200 can be factorized, prime factorized as 2 to the power 4 into 3 to the power 1 into 5 to the power 2, right? Now 1200 has to be written in the form of x square into y, right? So from here we can say that both x and y would be the factor of 120, right? So x square is given, so we can say that x square would be a factor of 1200. So we need to find the number of perfect squares which are, or number of factors which are perfect squares. Number of factors of 1200 which are perfect squares, right? Because x square is there and we know that x square would be the factor of it. So x square, since it's a square, so it has to be a perfect square. So the number of factors which are perfect square can easily be identified by taking the number of ways the 2's can be used. We have the highest power of 2 to the 2 to be 4, then we can use 2 to the power 0 or 2 to the power 2 or 2 to the power 4, right? And 3 can be used as 3 to the power 0 only. 5 can only be used in 2 ways. So if I take any value from this particular column multiplied with any value, in fact the only value is 3 to the power 0, and multiply with any value of the third column, so whatever comes will always be factor of 1200, and it will always be a perfect square. Because perfect square, when we prime factorize, for example if 36 is a perfect square, we prime factorize, then every prime number, the power of every prime number is always even, right? So we have ensured that. So the number of factors which are perfect square would be, the number of ways of selecting one out of these 3 is 3, and definitely we don't have any choice for 3, so we will be taking only 1, and the number of ways where 5's can be used is this much, and which comes out to be 6. So this basically gives us an idea that there are 6 number of factors of this number 1200 which is a perfect square, right? So if I take one of those numbers, then suppose if I take this particular combination to get a factor which is a perfect square, then it comes out to be 2 to the power 2 into 3 to the power 0 into 5 to the power 2, which comes out to be 100. So 100 is one such factor of 1200 which is a perfect square. Now if I assign the value of x square to be 100, then the value of x would be either plus 10 or minus 10, right? Now further, what about the value of y? So if I assign the value of x square to be 100, the only possibility for the value of y is 12, right? That means we cannot have multiple values of y for one specific value of x. We'll always be getting one corresponding value of y, right? So the number of different values which x can take will give me corresponding value of y will be 1 only, right? So the number of different values of x would be, since x square can be the number of values which x square can take is 6. So the number of values which x can take is 12, because we can take plus or minus of this, right? Something like which we have done in 100. So just to clarify, then let me let me write down all those perfect square which are factor of 1200. So here if I combine these three, then it would be 1. The other number would be, if I combine these, then the number would be 5 square. And if I combine, say, this with this, then it would be 2 square. And if I combine this with this, then it would be 100. And if I combine this with this, then it would be 2 to the power 4. And if I combine this with 3 to the power 0 and 5 to the power 2, so it should be 2 to the power 4 into 5 square. So these are the 6 values which x square can take, and the correspondingly value of x would always be, say, plus minus 1, plus minus 5, plus minus 2, then plus minus 10, then plus minus 2 square, which is 4, then plus minus 2 square into 5, it would be 20. Right, so these are the 12 values which will x can take, and the corresponding value of y will always be exactly 1. Exactly 1, I mean to say, not the number 1, but number of values which y can take will always be 1. So the total number of pairs would always be 12 here. So 12 is the answer for this question. Now let's move to the next question. Now this is another specific kind of questions which appear, and here it says that the number of integral pairs we have to find. And one thing which we have to remember is that if the variable is introduced in the question, then the number of pairs itself means we need to find the ordered pairs. So how to solve these kind of question? I categorize this kind of question of the form a by x plus b by y is equal to 1 by n. So at the end of solving this question, I'll also give the shortcut formula for this, right? So such question which is 2 by x plus 3 by y is equal to 1 by 12. What we need to do is that we have to just make some kind of arrangement here. So we can write it as 2y plus 3x upon xy is equal to 1 by 12, or we can write it as it should be 24y plus 36x is equal to xy, right? So many a time in the questions you must have come across expression like this. There is two variable. So one term is the product of it, and the other two terms are just the sum of them, right? So whenever you come across such kind of expression, the only thing which you have to remember is that we have to factorize them. The moment you can factorize it, the question get cracked. So let me give an idea how to factorize it. So we know that I can write this particular thing as xy minus 36 of x minus 24 of y and equal to 0. I'm just leaving this space because at the later part I'll be using it. Now I have to factorize into two parts. So let me just take these two brackets. Now we need x into y. So if I take x here, so I have to take y here. So that x into y, when I open this bracket, I should get a term x into y, right? Now further, the coefficient of x is minus 36. So x should be multiplied with something at this place to get me minus 36, and that is nothing but minus of 36 only. So minus 36 should come here. Similarly for y, I have to take minus 24 here. So you can see that this term and this term will also appear when we expand this particular bracket, and there is one more extra term which will appear, and that is minus 24 when multiplied with minus 36. Since that term is not present here, so what we can do is that we can add that term on both the sides so that the equation remains unchanged, right? So we can say that this is also, this term will also appear when this bracket is open. So this entire thing is nothing but equal to this, and that should be equal to RHS, which is 24 into 36, or I can write it as 2 into 3 into 12 square, right? I have written it in this form deliberately because I have to derive I have to give the idea about the shortcut. So this form will help us to identify that how the shortcuts helps. Now since x minus 24 into y minus 36 is equal to this much, so let me factorize this. So it would be 2 to the power it should be 5, I think, and 3 would be 3 to the power 3, right? Now from here we have to take up a different approach to identify that in how many ways this particular number can be written as product of two natural numbers, right? So if I assume x minus 24 to be a and y minus 36 to be b, then the question reduces to this particular form, right? So we have to find that how many ways this number can be written as product of two natural numbers, correct? And that is given by the number of factors it has, right? And that is the concept which I believe that if you have gone through the number system, then you must have understood that the number of ordered pair, and wherein all the any specific number can be written as product of it, is given by the number of factors, and it is very easy to understand. So let me give a very simple example here, so that those of you who are not aware of it should also get this. So if I take a small number, say into b is equal to 6, I want to find that in how many ways 6 can be written as product of these two natural numbers, right? So the number of factors of 6 is 4. So a into b can be written as 1 into 6, or it can be written as 2 into 3, or it can be written as 3 into 2, or it can be written as 6 into 1. Since I need to find the ordered pair, so each of these particular term, if I compare one by one, so we get that a will be 1, b would be 6. Here the value of a would be 2 and the value of b would be 3. In this case it would be 3 and the value of b would be 2, and here it would be 6 and the value of b would be 1, right? So if you can see that these are the solutions of a and b, and the number of solution is nothing but the number of factors. So that is the logic here we will be applying. So we have to find the number of factors of this. So let me use this space. So it will be 2 to the power 5 into 3 to the power 3. So the number of factors would be 6 into 4, which is 24, correct? So the number of ways a into b or ordered pair solution is 24. Now in this case what we have done is that we have only taken the positive values, right? If a and b are any integer, then we could have also taken, in this particular case, if I take it here, we could have also taken the value of a to be, say, -1 and the value of b to be -6, that is both negative, or -2 and -3, or -3 -2, or -6 and -1, right? So if I want to take both positive and negative, so I can say that the number of pairs a b in this case, where the product is 6, is 8, which is nothing but 2 times the number of factors. So that thing can also be applied here, because it is said about the integral pairs, not the positive integral pairs. So the total number of pairs, both positive and negative, would be 24 into 2. 24 is the number of factors of this number multiplied by 2, so that we can get the corresponding negative pairs as well. So, and that is 48, but that is not the answer. At every time in this kind of question, you will find one pair which will give the value of x and y to be 0, and that is not allowed, right? I can just let you give you that number also, because we can write this thing as -24 into -36, right? Now a and b are nothing but x -24 and y -36. So if I assign these pairs, these numbers, to these particular terms, x -24 and y -36, you will find that the value of x and y would be 0, which cannot be possible, because no value of x and y equal to 0 will satisfy this particular equation. So here we can say that x is equal to -24, or x is equal to 0, sorry, x -24 equal to -24, and y -36 equal to -36. This is the only pair which we have to discard. Rest every pair will always give me a non-negative or non-zero values of x and y, and that we have to retain, right? So the answer here is 48 minus 1, that is this pair we have to discard, and that is 47. So this is the answer, right? Now let's come to the shortcut part of it. So the shortcut for such question is that if you look at this particular term, so this is nothing but 2 into 3 into 12 square, right? Now if I compare term by term this thing with this part, we can say that the value of a was 2, the value of b is 3, and the value of n is 12, right? So if I go through the entire process, what actually we have done is that we took, let me use this space, what we did is that we need to find the number of factors, say f, of the number a into b into n square, right? As you can see, we actually found the number of factors of this number, which is this, right? And the answer would be 2f minus 1, 2 times, because we need to find the we have to take the negative values as well, and minus 1 because there would always be one pair which will give me the corresponding value of x and y to be 0, and that need to be discarded. So this becomes the simple shortcut. So if you can use this shortcut, you can solve this question within 15 seconds, and if not, then definitely it's going to take a lot of time. Now let's move to the next question. Now we need to find that how many integral value of n exists such that this expression is also an integer. Now again we'll be applying the concept of binomial and numbers also here. So we all know that n to the power 4 plus 1 divided by n plus 1 is given, and we know that if I want to expand, say, x plus 1 to the power 4, then the expansion is x to the power 4 plus 4x cube plus 6x square plus 4x plus of 1, right? And if I take x minus 1 to the power 4, then in case of 1 I can substitute with minus 1, so it would be x to the power 4 minus 4x cube plus of 6x square minus of 4x plus of 1. So please remember that this is the expansion, which is nothing but the, if you have gone through the Pascal's triangle, you can verify that this is how we actually try to identify the coefficients of any binomial expansions, right? Now here for such kind of question, the very important thing is to target the denominator. The denominator has to be easy. If it is not easy, then definitely it's very difficult to say that or it will be very difficult to identify the value of the variable so that the entire expression is integer. So what we can do here is that, let me assume that n plus 1 to be x. So the corresponding value of n would be x minus 1. Let me substitute the value of n as x minus 1 in the above expression. So this expression n to the power 4 plus 1 divided by n plus 1 reduces to x minus 1 to the power 4 plus 1 divided by x, right? And one thing also is obvious, that for each corresponding value of x will get one corresponding value of n, correct? The only thing is that n should not be equal to minus 1, otherwise the denominator will be 0 and the entire expression will be not defined. Now let me use the expansion, this expansion, and substitute here. So we can say that this is x to the power 4 minus 4x cube plus 6x square minus 4x plus 1 plus of 1 whole divided by x. So if I take term by term, so it will be x cube minus 4x square plus 6x plus 4 plus 2 by x. We can see that for any integral value of x, this entire portion will always be integer. It will only depend upon the last term, and that is 2 by x. So 2 by x to be integer, we can say that x has to divide 2. So it's very easy to identify that x has to be factor of 2, and the factor of 2 are 2 and 1 and 2. But we can take negative values also, because we need to find the integral value. So we can take the value of x to be minus 1 and minus 2 as well. So these are the four values of x. So the corresponding value of n, if you want to check, would be, if I take the value of x to be 1, then the corresponding value of n would be 0, which we can take, because the only value of n which we can't take is minus 1, right? And for x is equal to 2, the value of n would be 1, and for x is equal to minus 1, the value of n would be minus 2, and for x is equal to minus 2, the value of n would be minus 3. So these are the four integral values of n for which this entire expression will also be integer. Now in this question we have to find the number of integral pairs xy such that mod of x plus mod of y is equal to 10. Again for such question we have a shortcut, and that shortcut is that mod of x plus mod of y, if it is equal to n, then the number of solution is given by 4n directly. So the answer for this question is 40. Let me just solve this question in a conceptual way so that you can also understand the process and approach also. So what we do here is that mod of x plus mod of y is equal to 10 given, so we can open the mods and it will become 4 straight lines, that is x plus y is equal to 10, then x plus y is equal to minus 10, again it will be x minus y is equal to 10, or minus x plus y is equal to 10. So these are the 4 straight lines which will be formed. So if I draw these into a xy axis, then it will be of diamond shape, or it will be a square. In fact, it will be kept like this so that the geometrical center is at the origin. So it will be something like this, and this portion is x plus y is equal to 0. Similarly, all other can be distributed to all 3 lines, but that will not be needed. And this point, this coordinate will be 10 0, and this coordinate will be minus 10 0, this coordinate will be 0 minus 10, and this coordinate will be 0 10, right? And we need to find that mod of x plus mod of y is equal to 10. That means we have to find all the integral values in this line, right? All in the perimeter of this particular square. Now we can see that this is one of the solution. 0 10 is one of the solution. If I put x equal to 0 and y is equal to 10, then this equation is satisfied. Similarly, 10 0 is also one of the solution. So this is 10. So we already have done that if x plus y is equal to 10, then the number of solution is 0 10 1 9 till 10 0, right? So the number of solution here is 11, including these 2 points. So in this particular line, including these two extreme points, the number of solution is 11. The same thing will happen for this also, but this particular point is already counted. So this point, if I include this point also, if this point is already being counted, so if I deduct that, so the number of solution in this case would be 10. The same case happened in this particular line also. If I include this particular point and this point is already been counted in 10, so here again it will be 10 counting this. Now if I look at this particular line, these two points are already been counted, so the number of points would be 9, the number of integral points. So if I add them, the addition comes out to be 40. So from here we can say that the average in all of these four areas, or in each of these particular straight line of these four areas is 10, and hence the number of solution has to be 4 times of this particular value. And that's the shortcut formula says that if mod of x plus mod of y is equal to n, then the number of solution is 4n. The only exception here is that n should not be equal to 0, because if n is equal to 0, then mod of x plus mod of y is equal to 0 has only one solution, and that is 0, 0. Right? Now let's take a slightly different question of a similar kind. So here again we have to find the number of integral pairs x and y such that mod of x plus mod of y is less than 10. So here what we can do is that we can use the knowledge or the concept of the previous question, that mod of x plus mod of y less than 10 can be assumed as mod of x plus mod of y is less than equal to 9. So what we can do is that for each of the values, that is for 9, for 8, for 7 till say 1, we can separately find the answers and add them. So for 9, the answer would be 4 times of 9, right? And for 8, if mod of x plus mod of y is equal to 8, then the answer would be 4 times of 8, and that will keep on going till 1, right? So what we can do is that we can write that the total solution would be 9 plus 4 times of 9 plus 8 plus 7 till 1. And for 0, as I said, that the only one solution, so we'll add 1 here. So this is the number of solutions. So we can say that this will be 4 into 9 into 10 by 2 plus of 1. So this goes by 5 times. So the answer would be 181. Now let's take the last question for this particular thing. Finding the number of integral solution of this expression. Now I'll not be deriving it because the derivation will take a lot of time. So just remember the shortcut formula for it, that mod of x plus mod of y plus mod of z is equal to n. The number of integral solution is directly given by 4n square plus 2. So here the value of n is 12. So straight away we can substitute the value in this particular shortcut formula to get the answer, and that will be 412 square plus 2. So whatever comes would be my answer. Now let's take the last question, and that is finding the number of integral solution xy to satisfy this expression. Now this is a very algebraic kind of expression. In fact, this is a equation of a straight equation of circle in fact. But what we can do here is that since there is a plus sign in between and both these terms are square, so that basically reduces a lot of our effort, because we know that x plus 1 whole square and y plus y minus 2 whole square will always be positive, or in fact it can be 0 also, but it will never be negative. Fine. And the sum of the two square gives me 50. So I can say that individually these terms should also be a perfect square, because x and y are integer, right? So if I list all the perfect square less than 50, then they are 0, 1, 4, 9, 16, then we'll have 25, then 36, then 49. Further we don't need to take, because anyway the number is 50, right? Now we have to make the combination so that the sum comes to be 50. So one combination looks as 1 plus 49 will give me 50, and the other combination is taking 25 twice. So what we can say that x plus 1 whole square is equal to 1 and y minus 2 whole square is equal to 49, or what we can do is that x plus 1 whole square is equal to 49 and y minus 2 whole square is equal to 1, right? And the third case is x plus 1 whole square is 25, as well as y minus 2 is also equal to 25. So if I take each of these cases, so let me take the first case. So if x plus 1 whole square is equal to 1, that means x plus 1 is equal to plus minus 1. So from here we'll be getting two corresponding values of x. So let me just use this, make a table for x and y. So If I take here plus 1, then the value of x would be 0, and if I take it minus 1, then the value of x would be minus 2, and the corresponding value of y would be y minus 2 whole square is equal to say 49. Then y minus 2 has to be plus minus 7. So if I take plus 7, then the value of y has to be 9, and if I take minus 7, then the value of y has to be minus 5, right? Or what we could have done is that 0 minus 5 will also satisfy this equation. You can see that if I put x equal to 0, then this term will be 1, and if I put y is equal to minus 5, then this term will be minus 7, but the square of minus 7 will be 49, which anyway will give me 50. Or we can say that minus 2 and 9. So for each of these particular relation, we are getting four solution. The same thing will happen for this expression as well as this expression. So the total solution is 4 into 3, that is 12, and that is the answer for this question.